All right, this is the first of two checkpoints for Module 13. Let's look at the first question here. So choose the statement that best explains the following statement. So bold and italic for explain. So, these first three, so what is this? This is an integral. So basically A is an integral. So what does an integral do? So yes, it is used to solve calculus problems. Multiplies f of x times d of x to get A. That's a little bit, I don't even know if I can say that's correct. It's the integral of a function. Yes, all those things may be true, but they don't really explain how this thing works. So we talked about Riemann sums in this module. Basically, an integral is what you get when you take a Riemann sum, which can be used to find the area of a finite number of rectangles and apply a limit to it. So you make that number of rectangles arbitrarily large, or equivalently the same thing, make those rectangles arbitrarily thin. So best explanation is this option here. If capital F and lowercase f are continuous functions such that the derivative of capital F is lowercase f, then what is this integral defined as? So this is essentially asking, if you know that f, lowercase f, is a function whose integral exists on some interval, and then the value of that integral is an antiderivative of the function, which in this case is capital F, evaluated at both endpoints, and we find the difference. So f of b minus f of a. Second option is correct. All right, question 3. The graph of f is shown in the figure above. If the integral from 1 to 3 of f of x is 2.3, and f prime of x equals f of x, then what is f of 3 minus f of 0? Okay, so a few ways to go at this. Here's the first way I'm thinking of. f3 minus f of 0, given that we have functions that are, capital F and lowercase f that are related this way, then this expression has to be equal to this. The integral from 0 to 3 of lowercase f of x dx. Do I know what the integral from 0 to 3 of f of x dx is? No. But I know what part of that integral is. So here's what I can say. This is an integral property we've dealt with. The integral from 0 to 3 of this function is equal to the integral from 0 to 1 of this function, plus the integral from 1 to 3 of this function. Do I know what the integral from 1 to 3 is? I think I do. I am given that it is 2.3. Which means, how do I find, what is this? So this is the graph of lowercase f. So if I can find the value of the integral from 0 to 1 of f of lowercase f, then I have what I want. So that is going to be the area under the curve between these two vertical lines. And conveniently enough for us, that's a rectangle. So what's the area of that rectangle? The area of that rectangle is 1 times 2 plus 2 times, or plus 2 plus, I'm sorry, plus 2.3. So I get 2 plus 2.3, that is equal to 4.3. So all these strings of inequalities go together to give me a final result of 4.3. Final result is the final choice. And question 4, the rate of change of the altitude of a hot air balloon is given by this function. Which of the following expressions gives the change in altitude of the balloon during the time the altitude is decreasing? Okay, so we can't assume it's decreasing over the entire time. So let's find where the altitude is decreasing. So where will that happen? The altitude will be decreasing where this rate of change of the altitude is negative. So can we find where that is? So R of t equals t cubed minus 4t squared plus 6. So this is a rate of change. So this is given in, we don't have units, but we don't really need them. Let's see if we can eliminate some of these choices. So if we want to change in altitude, we want to find the total change in altitude, which means we're going to need to integrate the rate of change of altitude. That is r, not r prime. So I can eliminate E and D right now. Now we just need to figure out what the interval is. So we have a cubic. Those are a little hard to solve, but we have multiple choices here, so let's go with that. What is r of 0? R of 0 is equal to 0 cubed minus 4, 0 squared plus 6. So that's 6. That's a positive number. So I think at t equals 0, the altitude of this balloon is not decreasing. So for that reason, I think I can throw out B and C. So now that I'm left with A, let's actually make sure that this makes sense. What is R of 1.572? That's equal to 1.572 cubed minus 4 times 1.572 squared plus 6. I'd really like for that to equal 0, so let's make sure it does. And indeed it does. So here's what I'm going to do. I'm going to assume that both of these values, 1.572 and 3.574, those are zeros for this function r. The last thing I want to make sure of is that a value in between those two values actually gives me a negative number, actually gives me a decrease. So let's do that. Let's pick r of 2. R of 2 gives me 2 cubed minus 4 times 2 squared plus 6. That's equal 8 minus 16 plus 6. That equals -2. All right, so all signs point to A being correct. Moving on to part 5. Choose the correct answer for A prime. All right, so let's say this. We're integrating lowercase f. So let's say that the derivative of uppercase f is equal to f of x. Basically, since I'm talking about the integral of a function, I'm going to give a name to its antiderivative because I know its antiderivative has to exist. So what does that allow me to do? So a is equal to the integral from a to x of f of t dt, which by the fundamental theorem of calculus, I can say that's equal to capital F of x minus capital F of a. But I'm not asked about capital A, I'm asked about the derivative with respect to x of a. So that's going to be equal to the derivative with respect to x of f of x minus f of a. What's the derivative of capital F of x? Well, by the definition I gave up there, that is lowercase f of x. What's the derivative of capital F of a? Capital F of a is a constant, so that's 0. So what I'm left with is lowercase f of x, which is my first option.